Hello, I'm David George, CEO of the CRC for Rail Innovation. Over the life of the CRC, more than 500 participants from industry and universities have dedicated their time to researching and addressing a range of practical issues which face the rail industry. Together, we have developed the knowledge and solutions to take the Australasian rail industry to new heights. This video represents the true power of collaborative research between the rail industry and our research partners. We've identified key areas of interest, including level crossings, fatigue, wheel rail interface, driver training, urban rail and workforce development. Groundbreaking research has produced practical results and positive impacts for the rail industry. These will live on after the conclusion of the CRC for Rail Innovation in 2014.
Hi, I'm Roger Harris and I'm Program Leader of the Workforce Development theme within the CRC for Rail Innovation. What I was told when I first joined at the beginning of the CRC by most of the human resource managers, we're developing programs on safety induction for employees, or we're developing programs for this, and everybody's developing their own, and it's so expensive. If only we could have one decent course or one decent product, then we could all tap into that and would save us an awful lot of money, and also begin to try and standardise, make more consistent some of these practices across industry.
Rail historically has had people, it's been a job for life, so we've had people come in basically straight out of school, being trained up onto rail and a job for life. That doesn't happen anymore. Society's changed where we need to take people that are in their 30s, 40s and even 50s and turn them into railway men or women. We put together quite some time ago a basic induction for people coming to work on the track and need to understand the danger and what is around on near track work. And we worked with many other rail organisations, as the research projects do, provided our material, put it together and then had an agreement that would either use all that material or top it up with our own railway type need. We use that for our induction throughout ARTC, and we're in all states bar Tasmania. In some areas, if we have to do a bit more electrification type induction, we do that, but we've used that training, it's been quite solid.
These projects are not just things that have been done overnight. A lot of the projects have been going on for 2 years. They include information drawn from all over the world, as well as local information from rail organisations. Our project, which is P4, we focused on how the rail industry can attract and retain good quality people, how the industry can educate and train and develop people, and we've also looked at how the industry can find ways of recognising the skills that they may bring from elsewhere.
The wheel rail interface is the single most important engineering feature of a railway. It is what allows us to carry 40-tonne axle loads. It allows railways to run at up to 400 kilometres an hour. We have a suite of projects that various industry partners have been involved in. For example, rail squats, insulated rail joints, lubrication of curves and the optimisation of rail grinding. Curve lubrication and rail lubrication generally has been an interesting area for the Australian industry. What was significant about the curve lubrication project was that we trialled some various greases to see how far they would carry and to see what benefits we could get from the various greases. And we had to actually import some special ones that weren't in use in Australia, so that was very interesting information. To get the information on which brand is the best, you have to be a member of CRC.
I work for Horizon, which is the largest rail freight operator in Australia. We're sort of in the process of rolling out a new lubrication strategy across our network. After we reviewed our existing lubrication methodology, we felt that there's more room for improvement. There's multiple aspects of the research that we're using, right from the actual lubricant properties right up to how we put the lubricant on the rail, including assessment of effectiveness of lubricant. Right from the start, I have been involved with this project. I have seen how the project has unfolded, and I'm satisfied that it could not be any better.
Well, now we are in the Central Queensland University's heavy testing lab. This laboratory is purpose-built for railway research. The test rig behind me here, it was built for the CRC for Rail Innovation project to investigate new designs for insulated rail joints. One of the difficulties, of course, with testing on track is that you introduce risk. No one actually wants to test a new product and run real trains over it in case at some point it fails unexpectedly. So this rig was designed so that we could do the first stage of that testing in lab. We built it up from some of the components we have in the lab here, and of course funding from the CRC for Rail Innovation. The wheel rail area is very universal. Everyone's doing similar things, similar sleepers, similar rails, similar wheels, profiles, and so there's a lot of sharing, so any innovation we find will certainly have worldwide appeal in the wheel rail area.
My name is Chris Willems, and I'm a postdoctoral researcher at Queensland University of Technology. We've got a trial that's looking at testing or trialling 3 low-cost warning devices. We've got 3 trial sites, one in Victoria, one in New South Wales and one in Queensland. And we're collecting data in different operating conditions over these 3 sites for 12 months in shadow mode. These systems are overlaid on a vital train warning system, and these systems don't have any connection to the road user, so there's no road user interface, there's no flashing lights. And so at the end of that, hopefully there'll be enough safety qualification data that will be able to support a type approval process should any of these suppliers and railways want to go forwards with deployment. The human factors component of this project is investigating the effects of reliability of these warning devices on road user behaviour. In order to do this, we're using the CRC Advanced Driving Simulator. And this simulator is basically a real car on a motion platform that has 6 degrees of movement, and it's a very realistic sort of driving simulator and allows us to do a lot of things that would otherwise be unethical to do in real life. What we did is we developed the 3D environment around an actual crash that occurred in 2008 at Rungu in Queensland. A truck crashed into the tilt train. One of the outcomes of this investigation was that human factors may have been a contributing factor. And so we thought that was quite an interesting situation, and so we modelled the 3D environment around that layout. And then we got a whole lot of participants to participate in controlled conditions that looked at prolonged failures and intermittent failures. The Baseline Rail Level Crossing video project aims to develop a safety data collection platform, and with a particular focus on level crossings and near misses. So what this project's doing is using video analytics, so forward-facing video cameras, to evaluate the video on the line, so as trains go up and down, and the presence of events of interest. And basically we have researchers then that will look at those events of interest and determine what the causal factors were that related to a potential near miss. And also a data fusion approach to collecting data from everything from event recorders and automatic train protection logs, asset data, so things like geo-referenced track center line, signals, absolutely anything you can think of, and it's all geo-referenced into a single database that can be used for geospatial data mining and other types of analysis.
My name's Peter Skinner. I'm a professor in the School of Architecture at the University of Queensland. And I'm working on the project for station design guidelines within the Urban Rail program. The guidelines we're trying to write are of necessity are broad. They cover everything from the fastest, newest stations to the oldest stations. But in all those cases, people use them in a similar way. The operators need to run them in a similar way. and society has the same expectations of them. When we started on this project, we first of all researched the literature and then tried to put together a concept map that linked them all together. We started working out from the station to access around it, to the role of the station in the city, and then the larger, broader societal goals of transport, environmental sustainability, economy, forward planning for infrastructure and growth. The project that we've got kind of starts right at the point where the foot meets the platform, but then grows out beyond the site that the rail operator actually owns. What we're trying to do is just reinforce the basic performance objectives of the stations. The whole of society uses trains, and people who are elderly, who may have visual impairment, who may have language difficulties, that they can find their way easily through a station and they can use it comfortably. The station is a big part of people's lives. It's probably the second most visited building in their working week between their home and their office. And the quality of the station experience is important for our cities and for tourism and those sorts of issues. And it makes life better for the operators when the travellers are happy.
Thank you for watching this video. I'd also like to personally thank all of our industry partners, researchers and students for their contribution to making the CRC for Rail Innovation a success. For more information, please go to railcrc.net.au.